Chemical equilibrium, using notes from Brown and LeMay, they've been edited to include some IB content. First thing, let's kind of review, well, not kind of, but let's review the objectives for the unit to give us an idea of where we are going. And the way these are organized, here are the understandings that at the end of the unit you should walk away with a good understanding of these concepts, application and skills. Okay. And then over here is kind of extras that hopefully will come out as we study this unit. So at the end, you should realize that a state of equilibrium is reached in a closed system when the rates are equal in the forward and the backwards direction. There is an equilibrium law and a constant Kc that you should be able to derive and manipulate depending on a mechanism or a flipping of an equation. The magnitude also tells us something about the reaction system at equilibrium and its temperature dependency. Then there is something called a reaction quotient that we will look into, and that will allow us to determine which way the equilibrium or the system will shift to again regain equilibrium. And then finally, that a catalyst has no effect on the position of the equilibrium, just on the rate. So a catalyst typically will allow you to reach equilibrium quicker. Okay. Applications and skills, characteristics of physical and chemical systems in equilibrium. What is that equilibrium constant expression Kc? And can you write an equation for both a homogeneous and a heterogeneous reaction? And then to determine the relationship between different equilibrium constants for the same reaction at the same temperature. Okay, I'll let you can read the others if you'd like. Also, we are going to apply Le Chatelier's principle. Those are the topics for the SL content, which you are responsible, going on and including some topics that we will cover as the HL Chem class. Le Chatelier's principle can be explained by the equilibrium law, so we'll see how that equates. How the position of the equilibrium corresponds to that Gibbs free energy. So we're going to bring in the idea of entropy and enthalpy again. And then application of the equation delta G is equal to negative RT natural log of the equilibrium constant. So we're going to relate Gibbs free energy, that delta G, with that equilibrium. Okay, so that's an overview of the objectives. I'm thinking I am going to make this its own screencast, and then we'll start the content on the next. Right here it says the use of quadratic equations will not be assessed. That is true of the IB exam. That is not true of this class. You will be expected to apply the quadratic equation.